The customer buys what's marketed as an anti-detect browser, opens 10 profiles, and logs 10 accounts in. By the end of the week, half of them are flagged. The browser didn't do anything wrong on purpose. It just never actually faked anything. Under the hood, it was a stock browser wearing a different logo, and the platform read straight through it in a single session. That gap between what a product calls itself and what it technically does is the whole story of this niche. And it's why Antidetect browser has become one of the most misused labels in software. Today, I want to walk through what a browser actually has to fake, point by point, to earn that name for real. I run real proxy and cloud phone farms, and I put these browsers, multilogin, GoLogin, Cameleo, Adds Power, Dolphin Anti, and the rest, through actual multi-account setups every week. This isn't a checklist copied off a landing page. It's the list I genuinely run before I trust a profile with an account that matters. And I'm going to stay defensive and third person the whole way through, how a signal gets built and how a browser answers it. Not a script for beating any one platform. The stock premium trap. Start with the trap a lot of buyers fall into. Plenty of tools calling themselves anti-detect browsers are, underneath, a normal premium build with a profile manager bolted on top. A profile manager is genuinely useful. It keeps cookies, local storage, and sessions separated so one tab doesn't bleed into another. But separating storage is not the same as separating identity. If every one of those separated profiles still renders a canvas the same way, still reports the same graphics card, still speaks the same TLS handshake, a site can link all 10 of them back to one browser build in seconds. A real anti-detect browser has to touch the layers underneath the interface, not just the tabs sitting on top of it. Canvas, the drawing test. The first thing worth checking is canvas. A site quietly asks the browser to draw text and shapes onto a hidden canvas element, then reads the resulting pixels back out. Your specific mix of graphics card, driver, and operating system renders that drawing with tiny subpixel differences that never change between visits. A browser that fakes this well produces a different, but internally consistent, canvas result for every profile. A browser that fakes it badly either returns the exact same value every time, which is its own tell, or scrambles the pixels into obvious noise, which is an even bigger one. The goal is a different answer per profile that still looks like a real machine actually drew it. WebGL, the GPU leak. WebGL runs the same idea in 3 dimensions, and it leaks more than Canvas does, specifically your graphics card's vendor and model string. A lot of cheap tools leave this completely untouched, so every profile on the machine reports the exact same card, which quietly relinks every one of those supposedly separate identities. A browser doing this properly assigns each profile a plausible, different GPU string and keeps its WebGL rendering behavior consistent with whatever card it's claiming. A mismatch here, a rendering quirk that doesn't match the claimed hardware, is one of the fastest ways a profile gets caught. Fonts, a personal fingerprint. The list of fonts installed on a machine sounds like a boring detail until you realize how personal it actually is. It's a quiet record of every piece of software you've ever installed that happened to bring its own fonts along. Design tools, office suites, language packs, a site can query which fonts are available and get a surprisingly specific answer back. A browser worth using ships each profile with its own believable font list, not the exact same 40 fonts repeated across every window, and not a randomly generated list that no real machine would ever actually have installed. Audio stack, the quiet giveaway. Audio fingerprinting gets overlooked because nobody thinks of their browser as making a sound. A script feeds a signal through the browser's audio processing pipeline and reads the exact numbers that come back out. And those numbers depend on the hardware and software stack the same way Canvas depends on the graphics card. It's quiet, it's invisible, and a lot of tools simply don't bother touching it. Whether a browser spoofs its audio fingerprint and does it consistently with the profile's other claimed hardware is a fast way to tell the serious tools from the reskins. HTTP headers and the accept language mismatch. Canvas and WebGL get most of the attention, but plain HTTP headers still matter and cost nothing to check. The accept language header tells the site which languages a browser prefers in order, and it should match the locale a profile is claiming, and the language its interface is actually running in. The user agents string names a browser and operating system, and the order those headers arrive in is itself measurable and fairly consistent per browser build. A profile that claims to be a specific browser version but sends headers in an order nobody's real installation of that browser sends them in is quietly telling on itself before a single active script even runs. Townsend and locale. The geography check. Townsend and locale sound trivial next to canvas and WebGL, but they're some of the easiest mismatches for a site to catch because they don't require any deep technical reading, just a comparison against the IP. If a proxy exits through a country 3 time zones away from what the browser reports, or the locale is set to a language nobody in that country actually speaks, that gap is visible without a single active fingerprinting script running. A browser that fakes fingerprints well, but leaves time zones and locale on default, is solving the hard problem and missing the easy one. Screen, hardware, and the CPU story, screen resolution, color depth, how many CPU cores the browser reports, how much memory it claims, these round out the hardware picture a site builds. None of them are exotic to fake individually. The actual test is whether they agree with everything else the profile is claiming. A profile that reports a high-end graphics card, 2 CPU cores, and a screen resolution common on a 5-year-old laptop is telling 3 different contradictory stories at once, and a contradiction like that stands out far more than an honest average setup ever would. Hardware concurrency and device memory. 2 browser APIs worth knowing by name here are hardware concurrency, which reports how many CPU cores are available, and device memory, which reports a rounded estimate of total RAM. Neither number is secret, and neither is hard to fake in isolation. The problem is the same one as everywhere else on this list: believability. A profile claiming 32 cores and 2 GB of memory is nonsense no real machine would ever report. And a profile with 4 cores and 32 GB of memory is unusual enough to stand out on its own. The values need to land somewhere a real unremarkable device would actually land. Extensions and installed plugins. Some sites can probe which browser extensions are installed, and an unusual combination is its own kind of fingerprint, the same way an unusual font list is. A profile carrying a dozen obviously automation-flavored extensions, or none at all, when a real user's browser almost always has at least a couple. Both stand out for different reasons. This one is easy to overlook because it lives outside the classic canvas and WebGL conversation entirely. But it's read by the same systems looking for anything that doesn't resemble an ordinary browser. Keeping a profile consistent over time. One more piece that's easy to miss because it isn't a single value, it's a pattern over time. A profile that resets its fingerprint on every single session looks less like a returning user and more like a machine that can't hold a story together. Real devices are boringly stable. The same font list, the same GPU, the same hardware numbers, session after session for months. A browser that regenerates a fresh set of values too often, thinking that's safer, actually creates the opposite of consistency. An identity that never settles into anything a platform can recognize as one ordinary returning visitor. Replica and the local network leak. Replica exists for voice and video calls, and if it's left unmanaged, it can quietly expose a real local network address underneath whatever proxy someone thinks they're routing through. This one matters because it operates at a different layer entirely. It isn't measuring a graphics card or a font list, it's peeking straight at the actual network stack. A browser worth trusting gives real working control over this, not a checkbox that claims to block it while still leaking through a background connection anyway. How to actually verify a browser did its job? None of this has to stay theoretical. Public fingerprint testing sites exist specifically to read a browser's own signals back and report how rare the combination is. And they work exactly the same way against a profile inside an Antidetect browser as they do against an ordinary one. Open one inside a fresh profile, note the entropy score and which values stand out as unusual, then compare it against a second profile from the same tool. If 2 supposedly separate profiles come back looking suspiciously similar, or one comes back looking like nothing a real device would ever report, that's the browser failing the checklist, not a platform being unfair. Consistency over randomization. Here's the pattern running through every single item on this list. The hard part was never generating a value. Any tool can throw a random GPU string or a random font list at the profile. The hard part is making every value on a profile agree with every other value. So the whole thing reads like one plausible, boring, real device. A profile with a top-tier graphics card, a budget CPU count, and a 5-year-old screen resolution isn't hidden. It's flat, because the story it tells doesn't hold together. The browsers worth paying for treat every profile as one coherent identity, not a pile of independently randomized settings. What the proxy still has to do. None of this replaces a proxy, and it's worth saying plainly because it's the mistake I see most often. The browser handles the fingerprint story. It does nothing about the IP story. Run 5 perfectly faked profiles out of the same data center address, and they're relinked at the network layer. No canvas trick required. The browser's job and the proxy's job are two separate halves of the same picture, and skipping either one undoes the other. What a real anti-detect browser should never promise. And last, a word on the marketing itself. No browser that fakes every item on this list is undetectable, and any product using that word is telling on itself, because it doesn't understand its own limits. Platforms watch behavior too. Typing speed, mouse movement, account age, posting patterns, none of which a fingerprint touches at all. A browser that nails canvas, WebGlen, fonts, audio, time zone, and hardware consistency has done its actual job. Whether an account survives after that still depends on how it's used, and no piece of software gets to promise that part. This is the actual checklist I run every tool through before trusting it with an account that matters. I test these browsers on real multi-account setups, so the written reviews and the picks I actually trust are all at antidetectbrowser.org, along with which tools fake this list properly, and which ones are a Chromium build wearing a costume. No affiliate hype, no undetectable promises, just what actually held up under a real test. If you found this useful, subscribe, because next up, I'm putting some of the biggest names side by side and showing exactly where each one's fingerprint story falls apart. See you in the next one.